This is your worksheet for pre-calculus graphs of polar functions. I have to match the polar equation with its graph. So I'm going to use this. Let me find it. Boom. You can copy that. This is identification. It's r equals a cosine theta, or a plus or minus b cosine theta or sine theta. And then those are all the different features of these things. And then I'm going to, each one, most of the time, I'm just going to graph it using some different points. Okay, but it's good to know the format of it so that once you graph a few points, then you can draw it in. All right, the first one, well, I have to do this whole first section. So match each equation. 2 plus 2 cosine theta. Let me look at my chart. 2 plus 2, when both are the same, the number added, hold on, and the number in front of cosine, it's a cardioid. It's like a circle that looks a little bit like a heart. And when it's cosine, is this one cosine? Yeah, when it's cosine, it's x-axis symmetry. That means it's got the x-axis, it's equally far above the x-axis, equally far above and below. So it looks like a little heart. 2 plus 2, that's going to be a. See how it's x-axis symmetry? And it looks like a little heart. Okay, that's a. 2 plus 2 sine of theta, that's going to be the same thing, except it's going to have y-axis symmetry. It's going to look like a heart, and that's d. You see how it's got y-axis symmetry? That's because it's a plus a. Both the numbers are the same. It's a cardioid. Heart shape touches the origin once. Okay. 4 plus 3 cosine theta. So the a part is bigger. So a plus or minus b, a is bigger. It's a linicon, rounded with a dimple, no loop. So let's see, round it with a dimple, and cosine is x-axis symmetry. So x-axis symmetry, round it with a dimple, no loop, that is C. See how it's got the little dimple, no loop, and it's got x-axis symmetry. And now r equals 3 plus 4 cosine, where a is smaller. I keep forgetting, yeah, a is smaller. So this has a smaller loop inside, and cosine x-axis symmetry. So we need a small loop inside, x-axis symmetry. That's this one. That's B. I guess I should A, C, D, B. I should cross out the ones I've already done. R equals 5. That's going to be a circle centered around the origin. That's E. And R equals 2 sine theta. Here, the table even shows R equals A is a circle centered at origin. And then R equals 2 sine theta, it's going to be a circle. And then it says sine is x-axis symmetry. I'm sorry, sine is y-axis symmetry, so that would look like that. There's that y-axis symmetry. So there's F. So there's all those. Now I have a few more I have to do on this sheet. Let me look to see if I'm recording, which I am. I have to do number 17. 17, 1 plus 3 sine theta. So I'm going to go here, and I'm going to do 1 plus 3 sine theta. And I'm just going to graph a few points. So sine of 0, do you remember your unit circle? I need 0. Where's my unit circle? There's 0. Sine of 0 is 0. So 1 plus 3 times 0 is just 1. So at 0, it's at 1. 0 degrees. So here's 0 degrees. It's at 1. Right there. At pi over 2, sine of pi over 2, and a unit circle is 1. 1 plus 3 times 1 is 4. So it's 1, 2, 3, 4. It's up there at pi over 2. I don't care about these where they're 0, because anywhere it's 0, it's just going to be at the origin. All right, so pi, let's see, what is the sine of pi? Pi is 0, so 1 plus 3 times 0 is 1. So at pi, here's pi, and I go 1 in the pi direction. Okay, and then the 0 doesn't matter, again, because 0, it's like down there. It's right at the origin. All right, 3 pi over 2. What is the sine of 3 pi over 2? Do you remember? It's negative 1. So 1 plus 3 times negative 1 is negative 2. So at 3 pi over 2, it's negative 2, which means I go 2 away from 3 pi over 2. I go up there. And then at 2 pi, it should be 1 again, right? Because it's 0. 1 plus 0 is 1. So 2 pi is 1. Now I know 1 plus 3 sine 0. Let me look at my chart again. 1 plus 3, the A is less than, it's a limicon with a smaller loop inside. So I know this thing is going to go, it's going to go like that, and then like that, something like that. They're not going to hit you and make it too perfect, but that's what it looks like. And I will graph it exactly on Desmos. R equals 1 plus, I forgot what it was already, 3 sine theta. And see, it's that limicon, the limicon. And so that's it. Pretty good. Okay, I've got that one. So you can fill in values and then graph it. And if you know what the basic shape is, once you have memorized this table, then you'll be ready for the test. Okay, what's the next one? I have to do 17, I have to do 19. Where's 19? Theta equals pi over 3. Well, it's just anywhere that's pi over 3. Where is my graph? Pi over 3 is here. Theta equals pi over 3. It's just a line like that at pi over 3. It would actually go on forever. So theta equals pi over 3. All right, that was 19. Number 20. Hold on. Where's the questions? Number 20. Theta equals 7 pi over 6. Well, 7 pi over 6, that's here. Pi over 6. So let me get rid of that other one. This is 7 pi over 6, by the way. And let me show you that on the unit circle, just so you know I'm not making it up. There's 7 pi over 6. And so theta is 7 pi over 6. It's anywhere, it's a line like that. Okay, that was, I don't remember which one. That was 20. I have to do 22. Negative 3 cosecant. Well, cosecant and secant, a cosecant, a secant will be a straight line. And if it's negative 3, it'll be below the, what I would call the x-axis, but it's the below this, the horizontal axis there. So it's 3. Let me get rid of that one. I go 1, 2, 3, like this, and it's just going to be, as well as I can make it, a straight line. And if it was positive cosecant, positive something cosecant, it would be above the horizontal. If it's secant, it would be to the right. If it was negative something secant, it would be a vertical line to the left. Okay, so that's number, whatever it was, 22. I've only got one more, r equals 7. R equals 7 means I'm 7 away from the origin everywhere. 1, 2, 3, 4, 5. I have to draw, I don't know how I'm going to do this. I have to draw 2 more rounds of this. Well, that's not bad. So, you know, I don't want it to be too large. And I want it to be somewhat circular. Well, I guess it's got to be larger than that. Okay, that's good enough. But it's just going to be 7 out everywhere from the origin. 1, 2, 3, 4, 5, 6, 7. So it's going to be a circle. Whoop, I don't want to draw circles. I want to draw, it's going to be a circle on the 7th ring around the origin. That's just a circle. So that's it, some polar coordinates and graphing.